Good day again to everyone. Our focus today is the derivative. We'll focus our attention with the derivatives of the trigonometric function, specifically the tangent, okay, tangent function. So the rule is, if we have your function to be y is equal to tangent u, then the derivative is equal to y prime is equal to secant squared u times the derivative of the u. So that is what we are going to do. And so when we are going to illustrate this one, let's try to consider this problem. Okay, our problem in here is g of x, or g prime of x is defined to be 5 tangent 3x. Okay, 5 tangent 3x. So notice the given is actually a first derivative, okay, first order of derivative, that is g prime of x is equal to 5 tangent 3x. So what would be its derivative? Now in here, now we have to look for again or identify our u in here. Okay, so our u is actually 3x. Now, so after deriving now, or after identifying now the u, now we have to get its derivative. So the derivative of u is u prime is the same as 3. Okay, now having said this one, we can now have the derivative or second order derivative of the 5 tan 3x. So we have in here g double prime of 5. Now what is tangent? So tangent is actually secant squared 3x. Okay, 3x. But in here we have to multiply this tangent 3x with its u, which is 3x, and the derivative of the u is the same as 3. Okay, so ayan. Okay, again, our focus in here is to apply the trigonometric function, specifically the definition of function that is tangent u. So if your function is defined to be tangent u, then its derivative is secant squared u multiplied by the derivative of the u. So for example, we have in here the problem g prime of x is equal to 5 tangent 3x. Now what is the second derivative of this one? As you can see, this is the first derivative. What must be the second derivative? Now again, in here, to look for its derivative, we have to identify the u. So our u in here is the same as 3x, the coefficient of tangent. Okay, now after identifying now the u, get its derivative. So we have in here u prime is 3. So we are now ready to get the derivative of g prime of x is equal to 5 tangent 3x by saying g double prime is equal to 5 multiplied by what is tangent. What is the derivative of tangent? That is secant squared u. So secant squared 3x. Okay, multiplied by the derivative of u, which is the same as u prime is equal to 3, that is the same as 3. So the derivative now would be g double prime of x multiplied as 1, that is 15 secant squared 3x. So that is the derivative of the problem. Okay, so that is the derivative of the problem. We'll put it in a box so that at least it is identified. Okay, so next The next one in here is we have a problem number 2. F of theta is equal to tangent squared 5 theta. Now, how are we going to get again this one? Now, notice that if we are going to get its derivative, we have to convert this one into its exponential form. So, we have in here f of theta is the same as we have the quantity tangent. Tangent 5 theta is the same as this one. Okay? So, when we are going to apply now in here, we have to apply the chain rule. So, we're now ready to get its derivative. So, how are we going to get the derivative? We have in here f prime of theta is what are we going to do with this one? That is to be multiplier. So, that is 2 multiplied by the tangent 5 theta. Okay, tangent 5 theta. Now, definitely, in the chain rule, we have to get the derivative of the term inside. Okay, so that is multiplied by secant. Okay, secant squared 5 theta. And of course, when we are going to get the derivative of this one, we have to get the derivative of 5x. So that is the same as we have in here multiplied by 5. Okay, multiplied by 5. And so our final result would be f prime of theta is the same as multiply this one to this. It will give you now that is the same as 10. Okay, 10 tangent 5 theta secant squared 5 theta. Okay, so that is the derivative. So notice that when we get the derivative of this one, we apply the chain rule that we have already discussed last time. Okay, so next, for our number 3, our trigonometric function is y is equal to 3 tan pi x squared. Okay, so in here, when we are going to get its derivative, we say y prime is the same as 3. Okay, 3 multiplied by what is tangent. Tangent is secant squared. Okay, secant squared pi x raised to 2. Okay, and of course, when we are going to get now the derivative of the u, our u in here is pi x squared, so that is to be multiplied by 2 pi x. Okay, now after that one, our y prime now is said to be y prime is equal to this one multiplied it in here, so we have 6 pi x secant squared pi squared. Okay, so that is our y prime. That is our y prime. Now, you might be saying, what is our u? Okay, so to identify our u in here is actually this one. Okay, so our u is equal to pi x squared. And so what is the derivative? Derivative is 2 pi x. So that is our multiplier. Now, following now our rule, so our tangent is actually secant squared u. What is our u? That is pi x squared, and multiplied by its derivative. 2 pi x. Okay, 2 pi x. So having said that one, we multiply now the 2 pi x to our 3, constant 3. That is the same as we have 6 pi x secant squared pi pi x squared. Okay, pi x squared. So that is our number 3. Now, what about for the number 4? To solve the number 4, which is h of x is equal to sine tangent 2x, now we have to identify again our u. So what is our u in the problem? Our u actually is tangent 2x. Okay, now in here, after identifying now our u, we have to get the derivative. So the derivative of u now is u prime is secant squared 2x. Okay, definitely we have to multiply the derivative of this 2x, that is multiplied by 2. Okay, so our derivative now for our u is u prime 2 secant. Okay, secant squared 2x. Okay, now because we are already done with the u, there's a time now we're going to get the derivative of h prime. Okay, so h prime, or get now the h of x, which is h prime of x. Okay, what is our sign? Okay, our sign is we have in here cosine. Okay, cosine. So we have cosine. What is our coefficient? Tangent. Cosine tangent 2x. Okay, cosine tangent 2x. Now after that one, multiplied by the derivative of our tangent 2x, which is our u. So that is the same as the derivative is actually 2 secant squared 2x. Okay, now having said that one, we multiply this one in here, so we have in here that is the same as h prime of x is 2 cosine secant tangent 2x. Okay, cosine tangent 2x secant squared 2x. Okay, so that is our derivative. Okay, or we might as well rewrite it by saying h prime of x would be 2 secant squared 2x. We have in here cosine tan 2x. Okay, so this one. So this is the derivative of the problem. Okay, number 5. Okay, so for our the next one in here is number 5. P of x is defined by tangent of tangent 2x. So how are we going to get the derivative of this one? The same rule that we have to identify what is u. So our u in here is tangent 2x. And then after that one, we will get its derivative. So the derivative of u is u prime is equal to secant squared 2x. Okay, 2x multiplied by the derivative of 2x, that is the same as 2. So it will give you now u prime of x is equal to 2x, or 2 secant squared 2x. Yan, 2x. So that is the derivative of u prime. Now, having said that one, we are now ready to get the derivative of the p of x. So p of x now is said to be p prime of x. Okay? Now, what is the derivative of the tangent? The derivative of the tangent of tangent 2x is secant squared. What is our coefficient? Tangent 2x. Okay? Tangent 2x. And of course, multiplied by the u prime. Okay? What is our u prime? So we have in here. So that is 2 secant squared 2x. So that is our derivative for the u prime. So for our final answer, that is bring this one in front. So we have 2 secant squared 2x, then multiplied by, that is the same as secant squared, this one, secant squared tangent 2x. So we have in here the p prime of x. So we might as well consider enclosing this one with parentheses. Okay, so we enclose this one with parentheses. Okay, so that if we are going to have now the final, this could be the final. If you continue, then you can still simplify that one, but that could be the final answer. Okay, so to solve for the number 6, we have to go over with the idea of the quotient rule. Okay, so remember, our quotient rule states that, okay, our quotient rule, okay, so for our quotient rule, if your function, okay, if your function is, we have in here d over dx of f of x over g of x, this must be what? This must be g of x times the derivative of f. So we have f prime of x minus f of x times the derivative of g prime or g of x, which is g prime of x. And of course, our denominator must be raised to the second power. So g of x, okay, g of x is raised to the second power. So that is the rule that we are going to apply. So that in here, when we are going to solve for this one, we have to identify our numerator, which is f of x, and denominator, which is g of x. So what is our numerator, which is identified by the f of x? Now we have the cotangent, okay, cotangent x. After identifying our f of x, it says in here we need to have its derivative. So what is the derivative of the cotangent x? So the derivative would be f prime of x is equal to, that is the same as negative, okay, negative cosecant squared x. Okay, so that is the derivative of the cotangent x multiplied by the derivative of our u, which is x, that is 1. So still that is negative cosecant squared x. Okay, so let's try to identify so that we will not be confused. So this is the f of derivative of f of x. Okay, now another one is we have to identify now our denominator, which is represented by g of x. So our denominator is g of x is equal to sine x. Okay, so g of x is equal to sine x. Okay, sine x. So that having this one, we have to get the derivative. So what is the derivative of g of x? That is g prime of x, okay, is equal to cosine x multiplied by the derivative of x, which is 1, still cosine x. Okay, so we have now in here. Okay, and so after having this one now, we are now ready to get the derivative of the function h of x. So to get the derivative of h of x, we apply, okay, we apply this one. Okay, so we have in here now, let's try to do it in here. D over dx of h of x, okay, is equal to, so we have in here, okay, we have in here g. What is our g? That is sine, okay, sine x. What is the derivative of the f of x? We have negative cosecant squared x, okay, minus, what is your f of x? Cotangent. So we have cotangent x now multiplied by the derivative of g of x, which is g prime. So we have in here multiplied by cosine. Okay, so we have cosine x. Okay, so yan. Now after that one, we have to divide it by with the square of g of x. So what is our g of x? So we have sine x. Okay, so we have sine x. So we have in here sine x. So we have in here. Okay, now the derivative would be h prime of x. Now I will use the h prime of x. I will use the h prime of x. So to indicate derivative, h prime of x would be negative multiplied by positive sign. So we have in here negative sine cosecant and cosecant squared x. So no, change. Let's change, rewrite this one. Okay, so we have in here h prime of x is equal to negative sine x, okay, cosecant squared x minus, put this one in front. So we have in here cosine x cotangent x over sine squared x. Okay, so that is the final, okay, that is the final derivative. Yeah, that is the final derivative. So I hope you understand how to make use of this trigonometric function, specifically the rule on the tangent u, okay, which is equal also to its derivative, y prime is equal to secant squared u times u prime. Thank you and more power.